Consider the system of linear equations 2x minus 4y equals negative 10 and negative 3x minus 2y equals 7. A. Write the system of linear equations as an augmented matrix. B. Use Gaussian elimination to solve the system, writing the solutions as an ordered pair. So for part A, what we do is we look at the system of equations and we write the coefficients of the variables with the constants in a matrix form. In other words, it would be 2, negative 4, negative 3, negative 2, then a line separating the constant terms of negative 10 and the 7. So there's our augmented matrix. Now for part B, we start with this matrix and we perform row operations on the matrix so that we end up with ones along this diagonal here and zeros in the other positions of this side, leaving constant numbers over here. So the first thing I'm going to do is one of the operations would be to multiply row 1 by 1/2. So what that would give me for row 1 would be half of 2 is 1, half of negative 4 is negative 2, and half of negative 10 is negative 5. Now, at the same time in this step, I'm going to add row 1 to row 2. So row 2 plus row 1. Negative 3 plus 2 is negative 1. Negative 2 plus negative 4 is negative 6. And 7 plus negative 10 is negative 3. So let's draw in the vertical line separating the constant terms from the coefficients of the variables. Now what we're interested in, remember, is getting a 1 in this position, which we've done. Next, we would like to have a 0 in this position, which we can accomplish by adding row 2 plus row 1. So let's do that next. Row 2 plus row 1. However, the result I'm going to write here. We're not changing row 1 at all, so that's 1, negative 2, negative 5. However, row 2 becomes negative 1 plus 1 is 0. Negative 6 plus negative 2 is negative 8, and negative 3 plus negative 5 is also negative 8. Our vertical line, and then close the matrix. Next, what we'd like is a 1 in this position, which we can accomplish by multiplying row 2 by negative 1/8. So that gives us a result of, again, we haven't changed row 1, so that's 1, negative 2, negative 5. Row 2 becomes 0, positive 1, our vertical line, close the matrix. So the only thing that we have left to do is to create a 0 in this position. We do that by simply adding row 1 plus 2 row 2s. So row 1 plus 2 row 2s. Once again, let me write that answer here. Now in this case, we are changing row 1. So let's look at that. What we have is row 1 plus 2 times row 2. So 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1 is negative 2 plus 2 for 0. Negative 5 plus 2 times 1 would be negative 5 plus 2, which is negative 3. We're not changing row 2 at all, so that's 0, 1, 1, our vertical line, and then close the matrix. So what we know from this is that the value of x is negative 3, and the value of y is 1. So if we write that as an ordered pair, it would be the ordered pair negative 3, 1.